All right, so we're going to talk about subtracting mixed numbers with borrowing. This is a little bit more complicated than just adding or subtracting mixed numbers. You've got to really think about it and think back to what you've done in the past when you weren't able to subtract. You've had to borrow. So, like if I had the problem 31 minus 27, you said back when you did this, you said, okay, I got to subtract 1 minus 7. Well, if I have one thing, I can't take 7 of them away. It's not, we can't do that. So what we had to do is we had to borrow across. We had to take 1 out of here. And that, or not 10, but it became 11. And you would have said 11 minus 7 and gone from there. Guys, it's going to be kind of the same concept here. We're still going to have to borrow, and I'll show you why. It's one of those things you're gonna have to, you're not even gonna know necessarily just looking at the problem, that you're gonna have to borrow later. So let's work through here and let's see what happens. I'll show you a way to do it with borrowing, and then I'll show you a way that you can actually subtract these where you don't have to borrow. It's just a little bit more steps. So just so that you are familiar with both ways. You need to pick one way that it works for you, and that's the way that you need to work, okay? So watch both of these, see which one makes more sense to you, and that is how I would like you to be working it. I don't care which one it is, as long as it's the one that works better for you. So let's look at A here. We have 3 1/3 minus 2 1/2. Now, if I were going to set these up and subtract, I'm going to think I've got 3 1/3. And I want to subtract 2 1/2 here. Alright, now remember we have to get these to have a common denominator. In order to do that, we've got to think of our least common multiple between our two numbers that are denominators. So between 3 and 2 here, I'm looking to see what is my least common multiple there, which would end up being 6 if you were to list them out. So I want to get my new denominator to be 6. In order to do that, I've got to multiply this one, top and bottom, by 2. And my new denominator is going to end up being 1 times 2 gives me 2. 3 times 2 gives me 6. So that would be my new fraction there. Here, in order to get my denominator to be 6, I've got to multiply top and bottom by 3. Well, I'll do 2 times 3 gives me 6. That's what I wanted. 1 times 3 is going to give me 3. So these are my new fractions that I'm going to be subtracting. Now, notice here, and I'm going to rewrite this so this is a little bit more clear. I'll just use the same color, but I'm going to rewrite it over next to it. I'm going to have 3 2/6 minus 2 3/6. So we can ignore this right now. When I subtract, we've got to think from our right to left. So you're going to be looking at the things on the furthest right first. Think about 2 minus 3. Well, if I have 2, I can't really take 3 away. So what I'm going to end up having to do is borrow. And I'm going to do this in a different color, so hopefully it stands out a little bit more. Maybe I'll use red. What I've got to think about, and a lot of people were talking me through this in class the other day, and they knew that we had to cross these out, and we had to take 1 from the 3, so it's going to become a 2. But we struggled with knowing what to do over here with this guy. Remember, you just took 1 away from the 3. You took 1 number, 1 whole. That's all you took. So in order to balance this off so that I'm not just changing the value of this here, I've got to add 1 to my number here. Which if I want to do that, I know, and I want to be keeping my denominator the same so it doesn't get all crazy and messy. If I know that 6 over 6 is the same thing as 1. So if I had a pizza and it was cut into 6 pieces and I have all 6 pieces, I have the whole pizza. So 6 out of 6 is the same thing as 1. All I did is I took 1 off of here, took 1 away from the 3, and I just added that 1 back over here as a fraction. Okay, now let's see what that looks like as a subtraction problem. Again, I'm going to rewrite it down below. So I'm going to now have this new number 2, and my new fraction is going to be 2 plus 6 here, be 8 over 6. So make sure that you are adding these two fractions together. Subtracted by 2 and 3/6. So when I subtract these, now I'm thinking 8 minus 3, and I'm going to get 5 over 6. That denominator does not change, and I think 2 minus 2 is going to give me 0. So that's all I have to do. I'm done. This guy gave me 5/6. Okay. Now the most confusing part with this problem for most people is adding this 6 over 6 over here, and we don't want to do it. We struggle with wanting to do that. Just make sure you're taking one whole away from this 3. Make sure you've got to add that 1 back over here, because otherwise you're changing the value of that number, and we don't want to change the value. We're going to do another method really quick of this same problem just to see it may be a little bit easier for you. So if you like that first method, if that made perfect sense to you, you may want to skip this part of the video, okay? If you are not sure and you want to see another method, maybe to see if that is going to help you out, keep watching, because I'm about to try another one, okay? So this other method that I'm going to talk about, what we're going to do first is change our numbers over to improper fractions before we do anything. So I'm going to think about 3 times 3 is going to give me 9, plus 1 is going to give me 10 thirds, minus 2 times 2 gives me 4, plus 1 gives me 5 halves. Alright, now I want my numbers to have a common denominator. Again, it's going to have to end up being 6, because we still have these same denominators here. That didn't change. We know that our denominator is going to have to be 6. So in order to do that, I've got to multiply this guy by 2 on the bottom, multiply it by 2 on the top. This one over here, I've got to multiply by 3 on the bottom and 3 on the top. So when I do this, I get 10 times 2 gives me 20. 3 times 2 gives me 6. Minus 5 times 3 gives me 15. 2 times 3 gives me 6. And now all I'm doing is 20 minus 15 is going to give me 5/6. Alright, and I don't have to simplify that any further. It's as nice as it's going to ever be. So that's going to be my final answer. Okay, so again, this is just another way to work it. I got the exact same answer down here as I did above, and it's just another way to work it. And some problems, this may be way easier. Like this problem, this ended up being way easier. Some problems, it may seem a little bit messier. So it really just depends on what you want to do, okay? Whatever your brain sees. Again, I'm going to do this one the same way. I'm going to do both ways of showing this problem over here. So the first one, I'm going to do the stacking method. I'm going to do 4 1/5, and I know that the way I do my fractions is a little weird. 1/5 there, and I want to subtract 1 and 1/4. So now I'm going to be trying to find a common denominator as always. I know with 5 and 4, my least common multiple, if you guys worked it out, is going to give you 20. So I'm going to multiply this one by 4 on the bottom and 4 on the top. Multiply this one by 5 on the bottom and 5 on the top. I am going to end up getting some new fractions, and I'm just going to rewrite it over here. 1 times 5 gives you 4. 1 times 4 gives you 4. And 5 times 4 gives you 20. I'm subtracting 1. 1 times 5 gives me 5. 4 times 5 gives me 20. Alright, so again, I have this problem where I want to subtract here, and I want to do 4/20 minus 5/20, but I can't take 5 away from 4. So again, I'm going to have to do this weird borrowing thing. So I'll do this in another color as usual. I've got to think about, alright, I'm borrowing from this 4. I'm just borrowing one whole. And if I'm borrowing a whole here, I've got to add it back over here. And I want to keep that same denominator. again, if I have 20 over 20, if I have 20 of all of my 20ths, then I've got a whole. So I'm just adding back a whole on this side. I did not do anything to change the value. I'm just changing the way it looks. Now here, I'm going to rewrite my fraction once again so that hopefully it's not going to be as crazy. So I'm going to have 3 as my number here now. 4 plus 20 gives me 24 over 20. Oh. And then I am subtracting that other fraction that did not change at all. No. So now I'm doing 24 minus 5 is going to give me 19 over 20. 3 minus 1 is going to give me 2. And I am done. I don't have to do any more. So my answer to this one would have been 2 19/20ths. Okay. Now again, I'm going to show you how to do this other way with this problem, and see if you like the other way better. Again, if you liked the first method, you don't have to worry about trying to watch a second one. So I'm going to erase this really quick, and we're going to try this second method. Alright, so remember for the second method, I'm going to need to change my numbers over to improper fractions. So 5 times 4 is going to give me 20, plus 1 gives me 21 over 5, minus 4 times 1 gives me 4, plus the 1 gives me 5 over 4. Again, I've got to get everything to have a common denominator. So that common denominator is not going to change. We still have our denominators as 4 and 5. And so our common denominator, the lowest one that I can have, is 20. So again, I'm going to find that for everything. So 5 times 4 would have given me 20. So I've got to multiply that on the bottom and the top. 4 times 5 would have given me 20. Got to do that on the bottom and the top. So my new values here, or my new fractions, I'm having 21 times 4, which if you're having trouble finding that, just do it out on the scratch paper on the side. 4 times 1 gives you 4, 4 times 2 gives you 8. You have 84 over 5 times 4 gives you 20. 5 times 5 gives us 25. 4 times 5 gave us 20. So now we have common denominators and we can subtract. Now I've got to do 84 minus 25. Now, if you're having trouble finding this, again, just do it over in your scratch paper. 84 minus 25. And I have to borrow here. Okay, so 14 minus 5 would have given you 9. 7 minus 2 gives you 5. So I have 59/20ths. If I want to figure out what this is going to be as a mixed number, I'm going to do 20 goes into 59. It's going to go into there 2 times. 2 times 20 is going to give you 40. Subtract here, get 19. So 20 went into 59 2 whole times with 19 out of 20 left over. And there's my answer. So honestly, I think this way is a little less complicated. The only problem is you've got to remember to change your mixed numbers to improper fractions. And then when you're done, if you can, change it back to a mixed number. Okay, so it does add a little bit of a few steps in there. But to me, this is almost simpler just because you're not having to worry about the borrowing thing so much. But it's whatever your brain sees. I do not care what you use as long as it is correct, okay? So use what you want. But I hope this has helped. And again, good luck.